All right, seventh grade, we're continuing on here in chapter 7 today with a focus on experimental probability and theoretical probability. Now, first we're going to focus on experimental probability. Experimental probability is the number of times an event occurs over the total number of trials. So, something happened, like, say, flipping a coin. It landed, you flipped the coin 50 times. It landed on heads 27 times. The experimental probability of the coin landing on heads would be 27 out of 50 because it landed on heads 27 times and you flipped it 50 times. That would be the total number of trials. So, use the bar graph to find the experimental probability of the event. Well, we had a spinner. And this is a bar graph that represents how many times. This is the number that was spun. All right, this is how many times it would spun. We can see, well, it was spun a 1. Well, that's going to be between 6 and 9, but it's closer to the 9, so we know that's 8. The 2, it was spun 12 times. The 3, it was spun, well, it's between the 3 and the 6, but it's closer to the 3, so we know that's going to be 4. And the 4 then was spun 9 times. So that helps us here a little bit. We also know that we're going to need to know the total number of trials. So we're going to have to add all these numbers up. 8 plus 12 is 20. 20 plus 4 is 24. 24 plus 9 is 33. So let's make a note of that number. 33. That's going to be an important number because we need to know the total number of trials. So, use the bar graph to find the experimental probability of the event. Well, number 1, spinning a number less than 3. Well, the numbers that are less than 3 are 1 and 2. We spun a 1 8 times, a 2 was spun 12 times. The number of times that happened, 8 plus 12 is 20. The total number of trials is 33. So number 1 would be 20 over 33. That's not hard. Not spinning a 2. So not spinning a 2 would be anything that wasn't a 2. Well, 8 plus 4, we're going to just skip 2. 1 8 times, 3 4 times, that's 12. And then a 4 was spun 9 times. 8 plus 4 is 12, plus 9 is 21. So the experimental probability would be 21 over 33. However, you may notice that 21 over 33 is not in simplest form. As a 7th grader, you're going to have to put your fractions in simplest form. 21 and 33 are both divisible by 3. 21 divided by 3 is 7. 33 divided by 3 is 11. So I look at 7 over 11. That is in simplest form, because the only number that can go into both 7 and 11 is 1. Going on to the next one, spinning a 2 or a 4. So spinning a 2 or a 4. Well, when I spin a 2, that's 12 times. Spinning a 4 is 9 times. 12 plus 9 is, once again, 21. So the experimental probability of spinning a 2 or a 4 is 21 over 33, because 33, once again, is the total number of trials. Well, it just so happens to be the same answer. So I can, with confidence, say that in simplest form, it's 7 over 11, because the only number that can go into both 7 and 11 is 1. The last one here says spinning a 9. Well, there was no 9 on the spinner. It was just 1, 2, 3, or 4 on the spinner. So the probability of spinning a 9 is 0. It's not possible because there's not a 9 on the spinner. Ladies and gentlemen, that's experimental probability. Not bad. All right, let's move on. Let's go to theoretical probability. Let's go ahead and bring our other board over here. Use the spinner to find the theoretical probability of the event. Well, experimental probability, remember, was the number of time an event occurs over the total number of trials. Well, theoretical probability is a little bit different. The probability of an event taking place is the number of favorable outcomes. You remember back from lesson 1 in chapter 7, favorable outcomes, the things that could happen that fit the situation. That was a favorable outcome over the number of possible outcomes. You'll remember we had marbles in a bag, and there were like 2 green marbles. And so the favorable outcomes of picking a green marble out of a bag that had, say, 12 marbles and 2 of them were green, and green, because there were 2 green marbles. All right, so here once again we have a spinner with 8 parts. Once again, it's perfectly round. Every section is the same exact size. We're just using our imagination. We want to know the theoretical probability of the event, which is the number of favorable outcomes over the number of possible outcomes. Well, we know when we spin, if there's 8 sections on the spinner, we know that there's going to be 8 possible outcomes. We're either going to spin a 1, a 2, a 3, a 4, a 5, a 6, a 7, or an 8. What is the theoretical probability of spinning a 3? Well, there's only one favorable outcome. The only favorable outcome would actually be spinning a 3. There's only one 3 on the spinner. But there are 8 possible outcomes. So the theoretical probability is 1 over 8. Spinning a multiple of 4. Well, this implies that you understand what multiples of 4 are. The multiples of 4 are the numbers that show up as answers in the 4 times tables. 4 times 1 is 4. 4 times 2 is 8. 4 times 3 is 12. So 4, 8, and 12 are all multiples of 4. So I go to my spinner, and I'm looking for multiples of 4. Well, here's 4, because 4 times 1 is 4. That's 1 right there. 4 times 2 is 8, so that's another one right there. But there are no more. So there are 2 favorable outcomes. A 4 and an 8 are both multiples of 4. So there are 2 favorable outcomes. But there's 8 possible outcomes. So my theoretical probability is 2 over 8. Now, once again, that's not in simplest form. These are both even numbers. So I can divide them both by 2. 2 divided by 2 is 1. 8 divided by 2 is 4. I get 1 over 4. 1 over 4 is in simplest form. The only number besides 1 can go into both 1 and 4. Spinning a number less than 7. Spinning a number less than 7. Well, if I go to my spinner, okay, and I look at my numbers, the numbers that are less than 7, well, I have 8 and 7. Those aren't less than 7. But 6, 4, 2, 1, 3, and 5 are all less than 7. So that's 1, 2, 3, 4, 5, 6 options. 1, 2, 3, 4, 5, and 6 are all less than 7. So there are 6 favorable outcomes of spinning a number less than 7. But there are 8 possible outcomes. So I get 6 over 8. Once again, not in simplest form. They're both even numbers. As a 7th grader, you've got to recognize that. 6 divided by 2 is 3. 8 divided by 2 is 4. I get 3 over 4. 3 over 4 is in simplest form. The only number besides 1 that can go into both 3 and 4 is nothing. So that is in simplest form. There is not a number besides 1 that can go into both 3 and 4. Ladies and gentlemen, that is theoretical probability. All right, we're going to look at one more part. Let me get my marker closed up here. Once again, kind of run out of board space, but we go to my trusty little paper here. This says the bar graph shows the results of spinning the spinner below 200 times. So here's a spinner. It's got 5 parts. Once again, we're using our imagination. It's perfectly round. All 5 of these sections are the exact same size. So it's equally likely, we talked about equally likely back in lesson 1, that it would land on any of those because they are all the same size. So don't worry about what it looks like. That's what we're going to imagine. So we have to compare the experimental and the theoretical probabilities. So we're going to go back to our definitions we want to remember. Experimental probability, the number of times an event occurs over the total number of trials. Theoretical probability, the number of favorable outcomes over the number of possible outcomes. So we are comparing the experimental and the theoretical probabilities of the event. Well, we spun it 200 times, and it tells us that we spun the 1 32 times, we spun a 2 45 times, we spun a 3 29 times, we spun the 4 53 times, and we spun the 5 41 times. So not all even, but we're not too far from what it would be. If we did 200 divided by 5, that would be 40. So we should spin each one about 40 times. It's never going to be exact, most likely, but we're not way far off from what the average would be. This is not a crazy idea of what could happen in spinning that spinner 200 times. So we want to know the experimental and the theoretical probabilities. Well, first of all, spinning a 4. Well, the total number of times an event occurs. So let's start with experimental probability. We spun the 4 53 times. So 53 is going to be our top number for experimental probability. We'll just put an E right next to that for experimental. And it's over the total number of trials. Well, there were 200 trials. So it's going to be 53 over 200. All right, well, 53 over 200, that is in simplest form. There is no number besides 1 that can go into both 53 and 200. Well, for theoretical probability, which is the number of favorable outcomes over the number of possible outcomes, spinning a 4, there's only one possibility. There's only one favorable outcome, and that's a 4. So that's going to be 1. Number of possible outcomes, well, there's 5 sections on the spinner. 1, 2, 3, 4, 5. So the theoretical probability would be 1 over 5. Well, let's go to spinning a 3. Experimental probability. How many times did we spin a 3? Well, 29. Okay, so 29 is going to be my numerator. How many times did I spin it total? I spun it 200 times. So it's going to be 29 over 200. Once again, for my theoretical probability, there's only 1 3 on the spinner. So there's only one favorable outcome. That's spinning a 3. The total number of possible outcomes are 5. And so once again, it's 1 over 5. All right, spinning a number greater than 4. Spinning a number greater than 4. Well, the only number on the spinner greater than 4 is 5. So the experimental probability, if I come over here and put my E, we spin a 5 41 times. So the experimental probability is going to be 41 over 200. There's no number besides 1 that can go into both 41 and 200. So that is in simplest form. The theoretical probability, once again, the only number greater than 4 is 5. So there's only one favorable outcome. There's only 5 possible outcomes. So once again, the theoretical probability is 1 over 5. Spinning an odd number. Well, spinning an odd number. The odd numbers on the chart are 1, 3, and 5. Okay? So if I'm going to find out the experimental probability, the number of times something happened, I'm going to have to add the number of times that we spun a 1, which was 32, the number of times we spun a 3, which was 29, and the number of times we spun a 5, which is 41. I'm going to have to add all those numbers together. So a little scratch work here. Let's zoom in here. 2 plus 9 is 12, plus 1, 2 plus 9 is 11, plus 1 is 12. Put the 2 down, carry the 1. 1 plus 3 is 4, plus 2 is 6, plus 4 is 10. I get 102. All right, well, so the experimental probability is 102 over 100 over 200, because that's how many times we spun the spinner. Now, I need to recognize as a 7th grader This ends in a 0, this ends in a 2, so they're both divisible by 2. That's some simple scratch work if you need to do some long division. 102 divided by 2 would work out to be 51. 200 divided by 2 would work out to be 100. So I would get 51 over 100 for the experimental probability. All right, so then for spinning an odd number theoretical probability, well, once again, the possibilities are 1, 3, and 5. So there are 3 different possibilities of favorable outcomes for my theoretical probability. But once again, there are only 5 possible outcomes. And 3 over 5 is in simplest form because the only number that can go into both 3 and 5 is 1. All right, we'll talk to you later, 7th grade. Bye.